This is the third file for Math 107 for homework number 3 on polynomials and rational functions. This is the last couple problems in this homework set, and it has to do with rational functions. And recall that a rational function has a polynomial in the numerator, called p of x, and a polynomial in the denominator. And we're looking now for the horizontal asymptote. That is a long-term behavior. Where is this function sort of trying to level off at? And there's some rules which you should have picked up from reading or from the lectures, and it has to do with the degree of the numerator compared to the degree of the denominator. So when we look through these problems, we can pick out the degree of each. What's the degree of 4? It's 0. Here you'd have to FOIL it out, but you could figure out what the degree of the denominator is. Let's look here. I've got a numerator of 2, a denominator of 5. Okay, this, they're both 4, right? And then you can figure out what's the degree of 1. It's 0. Degree of x is 1. Okay, so now you can figure that out. Once you figure that out, you can get an idea of what is, or you can find the horizontal asymptote. If the degree of p is greater than the degree of q, then the horizontal asymptote, which is a value of y, is y equals 0. Alright? And that's going to be most of the cases here. If the degree of p is equal to the degree of q, let me erase some of this. Okay, let's say they're equal. The degree of p equals the degree of q. Now what? Well, the root is the horizontal asymptote is y equal to a fraction, like in this case, made of the leading terms, or the leading coefficients. So there's an invisible 1 here and a 6 here. In this case, it'd be 6 over 1 or 6. The horizontal asymptote is y equals 6 in that case. So you can fill in the chart from here based on the degree of the numerator and the degree of the denominator. And now for this problem, you need to work with this particular rational function. So here in the numerator, you have this polynomial, 2x to the 4th minus 32, and the denominator, you have x to the 4th minus 32, or 36x squared, and that's your q of x. Now you need to find the vertical asymptotes. The vertical asymptotes are the values of x for which the denominator equals 0. So you said x to the 4th minus 36x squared equals 0. Obviously you're going to factor out an x squared, and then you have to work with what's left over, setting the factors equal to 0. And that will give you your vertical asymptotes, values of x for which the denominator is 0. The next question is, at what values of x does the function cross the x-axis? It crosses the x-axis when the numerator p of x is 0. So you have to set 2x to the 4th minus 32 equals 0, right? And you solve for your x. All right? And then you'll find the values of x where this function crosses the x-axis. What is the degree of the numerator? The degree of the denominator. Obviously they're both 4, so what is a horizontal asymptote? That is a horizontal asymptote, remember, is a value of y. In this case, it would be made up of the leading coefficients. And now after this, you find the values of the function at 8, that's supposed to be an x, 5, and 1. Alright? Is this an even or odd function? It's an even function, by the way. So that means if you figure out the right half of the graph, you just mirror it to do the left half of the graph. These values will give you some interesting information. So you take 8 and put it in this equation. 5, obviously you need a calculator. Put 5 into the equation and put 1 into the equation. And now you have to sketch it. So now I'll give you some hints on graphing these functions. Okay, let's say here's your axes. Can't miss that. Alright. And again, you should label, well, that was supposed to be a pin. No. Your y-axis and your x-axis. And remember, your y is your f of x. I know sometimes there's little points that people struggle with. Right. When you found the vertical asymptotes, you should incorporate those as dashed lines. Like say here was a vertical asymptote, put that in as a dashed line. Maybe there was another one over here. Well, okay, this is just a general hint. It doesn't apply to that particular function you just did. Now, the function will never cross this line. It's either going to go towards positive infinity or negative infinity, but you don't know that yet. Okay, the next thing to do is when you found those x-axis intercepts, mark them. Say it crossed the x-axis here, and maybe that's the only place it crosses the x-axis. So put that in as an x. Then the next thing you can put in, I put this as yellow, is that horizontal asymptote. Say the horizontal asymptote was y equals 0. So you can put that in just like a little dash line here, so you kind of know where things are going in the long range. Alright, you can cross this horizontal asymptote all you want, but alright. Now say you know some other values of the function. Maybe you know that the value that it's positive here, and you know it's negative here, and you know it's positive here, and let's say it's positive out here. Now you can sketch this function, and here's how you can do it. It crosses here, it's positive here. That means in this whole region it has to stay positive because it can't cross, it has no other x-axis crossing. This is like a bridge. So it might go like this, and then it's got to approach positive infinity here. On this side it's negative, but it has no other x-axis crossing, so it has to stay negative, and it will probably do something like that. See, by knowing that it's negative here, crosses the x-axis, it's got to stay on this side, and as it approaches the vertical asymptote, it either goes to plus infinity or minus infinity. Obviously in this case it has to go towards minus infinity, here positive infinity. Over here I know it's positive. As it approaches the asymptote, it's got to go positive. And now in the long run, it's got to approach this horizontal asymptote, so we'll go something like that. Over here, again, you would have it going up, and then it would come down and approach x equals 0, or y equals 0. So just to review this, mark your vertical asymptotes as vertical dash lines. Mark your x-axis crossings with x's. Put out here somewhere as a guideline the horizontal asymptote. In this case, y equals 0 was a horizontal asymptote, so I put it in like that. Then you need a few points in between x-axis crossings and vertical asymptotes to figure out what the sign is, and after that you just kind of sketch it in.